Okay, I think this is lesson 412 and we're still talking about quadrilaterals. The objective of today's lesson is to identify and use properties of parallelograms. Now, as we've observed before, a quadrilateral is a parallelogram as long as it meets either of the following requirements. One pair of opposite sides is congruent and parallel. And if you look, you've got AB is parallel to DC, AB to DC. The diagonals bisect one another, and I don't have diagonals on there, and I really can't draw them very straight with my pen, but I can try. Let me see, let me get my pen. Okay, so, well, oh, I had a crook there at the end. And then here we go. Okay, so if they bisect one another, that means those segments are congruent and these segments are congruent. There we go. Alright, so the diagonals bisect one another. Both pairs of opposite sides are congruent, so that means that we've got AD is congruent to BC, and then AB is going to be congruent to DC. And then we know they're parallel because remember the little arrows? Those tell us that everybody's parallel. Okay, let me find my clicker. Alright, and then the four consecutive angles are supplementary. So for instance, it says that angle A is supplementary to angle B, B is supplementary to C, C is supplementary to D, D is supplementary to A. So just to make sure you understand, you would say the measure of angle A plus the measure of angle B are going to equal 180. And when I'm working things like this, I just go clockwise and start writing everything down. So those are always going to work out this way with the parallelogram. So D is 180, and then last you got the measure of angle D plus the measure of angle A. My writing's getting sloppier. There we go, equals 180. Okay. Now then, there is, I'm going to go through one proof here with you just to show you how you can use auxiliary lines to help prove your point. Like here we're going to prove that quadrilateral ABCD is a parallelogram. And you see here I highlighted in yellow, you can barely see it. It says you need to show that each pair of opposite sides is parallel. And we're going to start by drawing a diagonal so you can use the triangle congruence property. So there's a diagonal. It's going to look like that. Well, when I get to the proof part, I'm going to be going through and I will draw the diagonal up and the figure up on top. Let me see, I got some slides here that I can skip. I'm going to go right to this one. Alright, now then, let me go ahead and draw that diagonal. It doesn't matter which way you draw it, I don't believe. I'm trying to remember what the proof is. Hold on just a second. Well, I didn't have to remember that after all. Silly me. Okay. First, you always write down your given, the quadrilateral ABCD with AB congruent to CD and BC congruent to AD. And that's going to be a given. Now, the second part is to draw the diagonal. Now, usually when you are going to prove a parallelogram, you are going to do something like this. And realize that auxiliary lines are always an option. There we go. So we're drawing that auxiliary line right there. It says construct segment AC, a diagonal of quadrilateral ABCD. And then you think, well, what is the reason that we can do that? Because 2 points determine a line. That's like one of our undefined terms at the very beginning of the semester. Okay, so what's going to be next? Um, I've got to prove that I got some triangles here that are going to be congruent. Okay, so if I can prove that AC is congruent to AC, then I know I will have some angle congruency by side, side, side. So AC is congruent to AC. You should be familiar with this one by now because we use it a lot, the reflexive property of congruence. And now that I've proven that, you can look at the picture and you can say, hey, I can prove those two triangles are congruent by side, side, side. Alright, so now we have congruent triangles. What are we going to have to prove next? Okay, now I'm going to be able to prove that there's some angles that are congruent. Because if I can prove, because you remember with parallelograms, you know that not parallelograms, parallel lines cut by transversal, you know that you've got alternate interior angles that are going to be congruent. So if I can prove that angles are congruent, that'll put me on the way to proving this is a parallelogram by showing that the sides are parallel. Okay? So you think about it, you've got angle BCA is going to be congruent to angle DAC. We also know that BAC right here is going to be congruent to ADC. And the reason that we know that is because if you'll remember what we learned not too long ago, corresponding parts of corresponding triangles are congruent. There, I have to say it to know what the letters are. CPCTC. So let's see. Yep, that's how it worked out. Angle BCA is congruent to angle DAC. Angle BAC is congruent to angle DCA. So that's going to lead me down the road of knowing that BA is parallel to CD. Because right here I've got this transversal. Okay? And I also know that AD is going to be parallel to BC. And I know that because remember, if I can prove that alternate interior angles are congruent, then the lines are going to be parallel. And that was the converse of the alternate interior angles theorem. Okay, you see how we're having to use information from that we've learned through the whole semester. Okay, so now that I've proven that opposite sides are parallel and I've got some congruent angle business going there, then I know that this is going to be a parallelogram based on the definition of a parallelogram. Now, these, I could have used the if-then statements on this proof, but I didn't really need them because I just had to think it out. But you still could have used if-thens. Okay, there are several more proof examples in the lesson 412, Types of Quadrilaterals. So you can go through and look at those to help you get better at proofs. And right now we're going to look at a couple of examples. In this one it says VXYZ is a parallelogram, and we're going to complete each statement. And they want to know what segment VU is congruent to. Well, if you'll remember the properties of a parallelogram, you'll remember that diagonals bisect each other. And whenever you bisect something, you cut it into two equal parts. So that means VU is going to be congruent to UY. Now they want to know, who is VZ parallel to? Well, it's going to be parallel to XY. And the reason for that is that opposite sides are parallel. And then ZV, where is ZV? Okay, right here. They just wrote it different than they did in part B. And they want to know who it's congruent to, and we know from our properties it's going to be congruent to XY. And then that one is because opposite sides are congruent. Now on this one it says, if you saw a farmer's field with 4 straight lines, how would you determine whether it was in the shape of a parallelogram? Well, one thing, we already have learned that we could go through and prove that sides were parallel, but if you're thinking about a plot of land, and especially depending on how big the field was, it's going to be kind of hard to prove that your lines are parallel. So what would be more sufficient is to actually measure the sides, and you would measure the opposite sides, and if they were the same length, then it's going to be a parallelogram. Doesn't necessarily mean it's going to be shaped the way I've got it pictured here. It could be shaped like a rectangle, because see, as long as the measures, see, you've got a parallelogram right there. This one, the green one, same thing. If I measured and my opposite sides were congruent, it's going to be a parallelogram. He could have it in the shape of a square, and if the opposite sides have the same measure, which with the square they all have the same measure, it's going to be a parallelogram. And you know, it could also be a rhombus, because a rhombus has all congruent sides, which means your opposite sides have the same measure. Actually, I think my rhombus looks more like a square than my square does. So just because I say it's a parallelogram doesn't mean that it's going to be that slanted looking rectangle. Okay, let's see, where are we at? Alright, what we've learned in this lesson is that if two pairs of opposite sides of a quadrilateral are congruent, then it is a parallelogram. If they're parallel and congruent, it's a parallelogram. If the diagonals of a quadrilateral bisect one another, then it's a parallelogram. And the fourth conjecture that we presented without a proof was that consecutive angles are going to be supplementary, which means that if I add the consecutive angles up together, they're all going to equal 180. Okay, so you should be going through the LMS lesson 412, Types of Quadrilaterals, Part 1, and complete the student guide. You also need to read pages 127 through 130 in the reference guide and make any additional notes that you need to, because remember, you get to use your notes on your test. Complete the following problems in the problem set. There's only 5, so you can handle it. And after you get finished with that problem set and the previous steps, if you still don't understand some of the concepts, you need to contact me or attend TOGA if you have any questions. And then make note of any general questions you may have for when you attend CC. And of course, please add your course and section number with all communication so I can help you faster. And that's going to be it for lesson 412. Thanks for listening.